Welcome to our webinar, Surviving or Thriving in the Future of Dairy Production. In answering that question, we will discuss how to be both profitable and sustainable. I am Corey Geiger, your host, editor of Hoard's Dairyman, and member of the editorial team that also publishes Hay and Forage Grower and the Journal of Nutrient Management. We are broadcasting from our cheese cave here in downtown Fort Atkinson at the historic W.D. Hoard and Sons Company building, commissioned by Wisconsin's 16th governor, W.D. Hoard. Our webcast is being sponsored by Syngenta Seeds LLC, producer of Enogen brand hybrid corn. Enogen corn is designed to be fed as a corn grain or a silage, and it has unique attributes that promote digestibility and feed efficiency. We'll also hear about how that improved efficiency can contribute to sustainability and provide financial benefits for dairy farmers. This webinar will feature three presenters today. Our presenters will welcome questions from our viewers during the final portion of this hour-long webcast. If you have a question for any one of our speakers, please type it into the questions portion of our GoToWebinar control panel, and we'll get it asked in the next portion, in the final portion of this webcast. Let's start first, though, with a poll question. Poll question number one, it's open to all the audience to participate. What are the top dairy industry concerns for your operation in the near term? Is production and market economics, long-term profitability, meeting environmental and sustainability challenges, costs of inputs, or other issues? So go ahead and answer that. There's some really strong ones that are coming through here, and quite frankly, probably cost of inputs and a little bit of market economics, they're somewhat tied into one another. So we'll wait till a good portion of our audience answers that question, and then we will see the poll results. So we're well over the midpoint here, actually approaching 2/3. So let's see what our audience had to say. The audience, the top on the list here is 46% is cost of inputs, and 37% is long-term profitability. And of course, those are both tied into market economics, which is our third leading item. So it's my pleasure to welcome Dr. Dwayne Martin to our webcast. Dwayne is head of Enogen Marketing and Stewardship at Syngenta Feeds. Dwayne, can you share some insight about Syngenta Seeds and the Enogen trait technology?
Yeah, I sure can. Thank you, Corey, and good morning to the folks on the line for joining today. Your poll results really confirmed a lot of what we see in the market as well. So it's very interesting to watch as people respond to those questions. Let's just frame up where we are in the dairy industry today, and we'll talk a bit about what Enogen is and what it does, and take care of a couple of preliminary items before we go to Randy and John to present some of the new data that we've just released. So, you know, folks know their regional or their local markets. Nationally, there are about 9.5 million dairy cows in the U.S. At the latest count. You folks once again confirmed that, you know, even though prices are higher than they might have been 3 or 4 years ago, input costs are historically high, compressing our margins and making profitability very difficult in today's environment. Obviously, the other challenge here is that the non-farming public really seems to view dairy production as one of the big contributors to environmental impact and climate change. So how do we affect these factors in dairy as managers? Well, I tend to look at this in a very simple way. We need to do more with less. And that not only affects our short-term economic profitability, it also affects our long-term impacts on the environment and sustainability. We can't reduce production because we have to continue making gains to feed an increasingly large population, but we've got to do it more efficiently than ever before. So Enogen is a tool that producers can consider that's pretty easy to adopt in a dairy management or a dairy operation, and it's one that can really offer some significant benefits, not only in immediate production, but also long-term sustainability. So let's go to the next slide and we'll dig into it. Well, what is Enogen? An Enogen corn hybrid is just like a non-Enogen hybrid, except for one key factor. It contains a genetic trait that allows the corn plant to manufacture a very effective alpha amylase enzyme in the starchy endosperm of the corn kernel. And that enzyme does one thing and one thing only. It allows the rapid conversion of starch to sugar. So as we all realize, we're feeding corn to cattle primarily as an energy source. You unlock that energy when starch is converted to sugars that are usable by the animal. We first launched the Enogen trait in 2011 for use in ethanol production. We started researching it for livestock feed shortly after, and after successful research in that area, began selling our first Enogen for beef and dairy cattle feed in the fall of 2016 for the 2017 production year. So let's answer a question that we get immediately when we talk to producers about Enogen. You know, it sounds like there are some good benefits on the backside of this when we feed it. What if I lose those benefits up front with a poor yielding, poor performing hybrid? Enogen hybrids are grown, managed, harvested just like any other elite corn hybrid. There is no yield drag from the Enogen trait, and we're pretty transparent about this. We think it's good for the dairy industry. We want you to be growing some Enogen corn instead of the corn hybrid you're growing. So we don't price it any different than we would price a non-Enogen elite corn hybrid. So what are we going to review today? We've got really a growing database of information both in beef and dairy production, and we're going to pull one of those published studies from Penn State University today and talk a bit about the results of that study. We took those results, plugged them into a life cycle assessment that quantified some of the environmental or sustainability benefits that we see with Enogen, and then also plugged that into a University of Wisconsin economic calculator that will give you a good idea on what it can save in production costs. Let's go to the next slide, please, and I'll show you a bit of field research on the yield question. We've been researching and documenting Enogen yield versus non-Enogen isolines and competitive products since we launched Enogen in 2011. We've been doing it specifically on the silage side since about 2016. And the data come back the same way every year we do this. There is no yield drag due to the Enogen. And obviously, some of the silage-specific hybrids like BMR may essentially have some production challenges, so to speak. So when we start thinking about total digestible nutrients per acre, the yield, once again, consistent with a non-Enogen hybrid, and the increased starch digestibility that we see from Enogen hybrids really gives an Enogen silage hybrid the edge on TDN per acre. So once again, just to clarify that question, you don't lose anything in the production side of an Enogen corn hybrid for silage, and you're going to see that efficiency benefit when you feed the hybrid. Let's go to the next slide, please. Even though we've done the research for that period of time, we've also got a lot of commercial experience with Enogen, both for grain and silage. And our producers have told us the same thing that is reflected in the data. They like the fact that it's competitively priced. You plant it, you manage it, you harvest it just like you would any other elite corn hybrid. And then we also see some benefits in the silage pit, and then, of course, that efficiency benefit when we actually feed it. So for those of you that are interested in seeing what some of our Enogen producers have to say about Enogen, you can find it on Enogen.com. All of these testimonials are there for you to take a look at if you'd like to. So that's all from here. Corey, back to you.
Thank you, Dwayne. As a reminder to you and our audience, if you have questions for our panelists, please submit those questions into the GoToWebinar question panel. And the sooner you ask that question, more likely it will get answered on the air in the final portion of our webcast. We're going to go straight to our second poll question. And the poll question with audience interaction: what is the top feature you look for in a silage hybrid? Yield and tonnage, fiber digestibility, starch digestibility, or another quality measure. So go ahead and answer that. We'll give everybody about 15 seconds to make your selection here. And really going to be looking forward to hearing from our new next two panelists here, Dr. John Gazer and Dr. Randy Shaver, as they walk us through this journey on this silage hybrid here. So we're we just passed over the 50% mark here, so let's see what those poll results are. And we kind of have a tight three-way race here. We're 1/3 saying yield and tonnage, closely with the leading one being starch digestibility. And in third place, but 27%, we're looking at fiber digestibility. So our next guest will definitely be talking about those matters, and it's my pleasure to introduce Dr. John Gazer, who is a regular contributor to Hoard's Dairyman via his Feeding Fundamentals column, and is a columnist for the Hay and Forage Grower in his Feeding Analysis column. John is an animal nutrition research and an innovation director at River Laboratories in Watertown, Wisconsin. In addition, John is an adjunct professor with the Department of Animal and Dairy Science at the University of Wisconsin at Madison. Additionally, John is a principal at Cows Agree Consulting. Let's hand it over to John to talk about starch digestibility and how Enogen can help dairy producers improve the sustainability and profitability of their operations. John, welcome.
Thank you, Corey. I appreciate the invitation and opportunity to contribute today, to have the platform with the Hoard's Dairyman team, Corey, yourself. It's an honor. Following in Dwayne's footsteps, he introduced this concept of total digestible nutrients. And thinking back to when I was in graduate school under Randy, if you take issues with anything I have to say today, perhaps blame him. He helped get me to the point I'm at today. But learning from Randy back when he was doing developmental and really innovative and groundbreaking work on Milk 2006, I had a bit of effort and put forth in looking at some of that, but I didn't exactly understand total digestible nutrients and how impactful and meaningful it is in dairy nutrition, profitability, and also environmental stewardship. This TDN concept is one that we need to grasp hold of, and there are many different ways to estimate and figure out what is the energy value of our silage, how much milk can we get out of a ton or out of an acre. I've written about the concept a number of times. Here on this slide, an image that we have adapted from an article published in Hoard's Dairyman back in 2020. And I think this visual in the pie chart format helps us understand where the calories come from in corn silage. Corn silage is actually a fairly heterogeneous feed, and that'll be the biggest word I use today, I promise. But corn silage is like a TMR, in that there is silver and fiber, and then there's grain. And as we look at where the energy comes from in corn silage, that's what the bar chart, or rather the pie chart, breaks down here. So we see the orangish color and the reddish color corresponding to the energy from fiber and the energy from starch. What we recognize first is that roughly 75% of the energy in corn silage, to 85% actually, comes from carbohydrates. But focusing in on the fiber and the starch, fiber accounts for and is one of our focal points in ruminant nutrition, rightly so, because fiber accounts for both energy as well as intake in dairy diets. But when we compare and contrast the energy from fiber in corn silage relative to the energy in the grain and the starch, looks like starch contributes roughly twice the amount of energy that fiber does in corn silage. So that's an area that while the poll today suggests that roughly 1/3 of our attendees today are thinking about and focused on starch digestibility, in my experience, that's been something we've overlooked. So that starch digestibility is influenced by many factors, some of which are outside of our control and under Mother Nature's control, but we can also affect starch digestibility with kernel processing, the extent of fermentation, and also seed genetics. Next slide, please. So we're going to jump right into some of the data that Dwayne spoke about earlier, and I wear a few different hats. My relationship with Syngenta and the Enogen team dates back at this point 5-6 years probably at that point. First began doing some research and work through River Laboratory with samples that were submitted to the laboratory for feed testing, and so we estimated rumen starch digestibility, which I'll talk a little bit more about on the next slide. In this slide, though, as we wade into this digestibility concept, which is a strong factor relative to the energy that comes out of starch in our corn silage, I'll point out a couple of things. On the left-hand side, we recognize that corn silage will be different from year to year. I know for those of you out there that have been farming and feeding corn silage over the last years and decades, this year's crop may or may not respond like prior year's crop. And so I'll touch on what we might be able to expect in 22 silage here just in a moment. But one thing that's important from an agronomic perspective is to look at, in my opinion, seed genetics and how seed genetics perform year in, year out. So on the left-hand side of the slide here, we recognize rumen starch digestibility measures made at the laboratory, and it appears that Enogen has consistently increased rumen starch digestibility at the laboratory relative to other conventional hybrids, not only in 1 year, but in 3 different sequences. And so it looks like there's a fairly repeatable response talking to the Enogen technology. And then on the right-hand side, another factor we know that can improve or influence starch digestibility is the extent of time in the silo. Stay tuned. We'll carry a bit of discussion with this in an upcoming feeding fundamentals column. Put a shameless plug in for that, Corey. But as we look at fermentation, I know there's, and it's somewhat debated, there's a mindset out there that, you know, if we let corn silage cook out long enough, say 6 months to 12 months, that, you know, kernel processing or maybe seed genetics, it kind of becomes a moot point. The starch digestibility achieves optimal and a very high level. But what these data suggest is that there is a consistent and maintained difference in rumen starch digestibility tied in with the Enogen technology, as indicated in the green bars relative to the black bars as the corn silage ferments out. In the x-axis, we can see between day 1, day 150, and day 240 in the silo. So it looks like both categories will improve in starch digestibility, and we know that is kind of what contributes to corn silage feeding to its full potential, but it does look like there is a consistent difference despite the amount of time in the silo. So that's been pretty interesting. Next slide, please. So I'm vaguely speaking of rumen starch digestibility, and I need to now put my laboratory hat on and delve into the approach that River Laboratory uses to estimate rumen starch digestibility, which is a little bit different from some other commercial laboratories, but we need to dive into that here to understand what these data are showing us. So at River Laboratory, the approach has been to actually place corn silage samples in the rumen of 3 living live dairy cows, and then assessing the amount of starch digested after 7-hour incubation within the rumen. So it's a proxy for rumen starch digestibility, understanding that corn silage in the total mixed ration may be within the rumen for 6 hours, maybe 10 hours. It depends upon the dry matter intake and the feed passage rate. We won't get into that, a little bit more scientific discussion, but we use a 7-hour incubation to estimate rumen starch digestibility. So in the middle of the slide here, we see in situ, that means partially within the animal, where we actually put the silage in the rumen of the dairy cattle. We see the in situ 7-hour rumen starch digestibility. So that's a percentage of starch that is digested, is broken down at that time point. But that lab assay utilizes small bags that you could analogize to like a tea bag. So one thing that also is important to understand is just the amount of the feed that washes out of that bag. Just think of it like a big tea bag that's put within the rumen. In just a warm water rinse. That's something that's been discussed and is maybe a little bit more important on the protein side of nutrition and lab analyses, but it's something we also look at in terms of starch digestibility. And so we quantify both 0 or warm water washout starch amount, as well as the 7-hour rumen starch disappearance. And what we note here is that it appears there is a significant and fairly dramatic difference in starch disappearance or starch digestibility, if we want to think about that rumen estimate of 10 to 25% relative to conventional genetics. And the data presented on this slide represent a meta-analysis approach done by Dr. Shaver, who will speak here just in a little bit, where we have a wealth of data at our fingertips, and we were able to do some pretty complex statistics to evaluate the impact. One other couple, or I guess a couple other items I'll point out on this slide is there are some other maybe ways that we can evaluate and look for potential interactions with the Enogen technology. But when broken down and looked at the different relative maturity groups, it appears that Enogen has performed fairly consistently across a wide variety of relative maturities. With both the small particle washout and the 7-hour rumen starch digestibility estimate. Next slide, please. So I spoke to some observations at River Laboratory, and that's really where my exposure and relationship and experience with the Enogen technology began and has been rooted. And I've since been doing some private consulting work in conjunction with Dr. Shaver over the last few years. And in that role, we've transitioned to helping understand and coordinate research studies at universities, as well as some other evaluations, which we'll speak to over the coming half hour. I'm going to introduce a Penn State feeding study, and the results of which will be used in some different fashions. So the Enogen team has supported and conducted a feeding study at the Penn State University. I'm going to move through this slide pretty quickly. We can reference this later as need be, but it was a feeding study with high-performing cows where essentially one corn silage was swapped out for corn silage with Enogen technology. And I'll note that these were near isolines, so the base genetics was very similar, and we focused in on just the Enogen technology and what that's capable of doing. Corn silage was included at a pretty high rate, about 40% of the total dry matter, and these diets were very representative of upper Midwest or Eastern dairy diets. Next slide, please. The outcome of the feeding study was intriguing, and I'm going to focus on the center of this slide first and foremost. In my opinion, our dairy performance metric or benchmark of note today and into the future should be feed conversion efficiency. So as I think Dwayne mentioned earlier, what can we do with what we've got? Can we do more with less, or can we produce the same amount with substantially less? And what Dr. Hristoff, Professor Hristoff's lab, and his graduate student and researchers observed in this feeding study, which has since been published in the Journal of Dairy Science, was roughly a 3 to 5% increase in feed conversion efficiency when looking at total milk volume, total fluid milk, as well as energy corrected milk. That came by way of an increase in milk production per cow per day with no, and numerically, a decrease in dry matter intake. So that 1.47 versus 1.55 difference in feed conversion efficiency, it may seem like a small numerical change, but we're chasing 0.01, 0.02, 0.03 unit opportunities and increases in feed conversion efficiency to make a big difference on our bottom line. Through this study, also monitored components, and it didn't look like there was much of a negative, if in fact, maybe a positive response in component production as well. Next slide, please. So production is directly related, and feed conversion efficiency is related to our, I would say, our financial sustainability, our business sustainability, that profitability, recognizing that input costs are through the roof. As we turn the page on 2021 silage and we look toward 2022 silage this year, I'll put in a sneak preview for you all. I think Dr. Hutchins, myself, and others will be speaking about the 2022 crop year and some of our observations in the future. Here's our sneak preview. Looks like grain content, starch content's up in this year's silage. Maturity is average to maybe a little bit more mature, but starch digestibility looks to be pretty hard, looks to be pretty challenged for our 2022 crop year for Midwestern and Eastern growers and dairies. That is something, and a rude, I guess not a rude, but a tough fact that we observed first in 2021 relative to 2020 growing season. And it looks like it's going to carry on into 2022. So that'll be the focus of future discussions. But starch digestibility certainly looks to be something that we're going to be faced with managing around. But here on this slide, it's also important to think about environmental stewardship and sustainability, which tightly ties into, I would say, economic sustainability. So one of the objectives of Dr. Hristoff's research is to evaluate sustainability in greenhouse gas emissions. Here on this slide on the left-hand side, we have methane intensity, and the observations out of that trial suggest a significant decrease in methane intensity per unit of milk produced, per the output, for Enogen relative to the control. Fascinating data, certainly something that 3 to 5 years ago, you asked me about sustainability, methane, greenhouse gases, I thought, this is just a little bit voodoo. Over the last few years, coordinating and working closely with the Enogen team as well as other clients, environmental stewardship, sustainability is something that we have to better understand. We have to be part of discussion with our industry, with the end consumer, really driving this demand for more sustainably produced products. So that's going to be something we're going to talk about just a little bit more. And Enogen, as far as the technology, what it is, as Dr. Martin described earlier, it is amylase being expressed in the kernel. So as part of this research study, the amylase activity in corn silage samples was actually evaluated. And here we see a pretty sizable increase in expression of amylase within that corn silage after being fermented for 6+ months. So that was also interesting to note. Next slide, please.
So we're off to a poll question here. And before we take that poll question, John, really interesting insight there. 3 to 5% efficiency conversion may or may not seem like a big number to people, but when you figure out that half of your cost is feeding cows, and you can move the needle by 3 to 5%, that's a big number. And on the other, so that's a great area of genetics here with Enogen. And the other side of this equation is on the cow genetic side, there's a new trait out there called feed saved. And so we're bringing this both from, in this example here now with Enogen, from the corn silage standpoint, but also from the cow genetics. And we can really make an impact here through the genetics of feed and the genetics of cows. So let's go to this third poll question here, and this is audience interaction. How satisfied are you with your silage crop this year? Highly satisfied, both yield and quality are good. Somewhat satisfied, yield was down. Somewhat satisfied, quality was down. Not satisfied, yield and/or quality were not good. So go ahead and answer that. And obviously, this is a regional question depending on the growing conditions. And as people are answering that question, I want to remind our audience that once you take your poll question, you have the opportunity to ask our panelists questions here, and you can go to the GoToWebinar control panel, type in a question here. We'll see this at Command Central, and we'll get it sent out to the best panelists to answer that question. So we are now over the midway point, so let's see the results of that poll. And tapping the list is highly satisfied, both yield and quality were good. That's 38%. And then in the somewhat satisfied category, here we got a split poll. Yield was down 33%, and another group said quality was down 10%. And then finally, not satisfied at all was that 10% factor here. We're going to move from John Gazer here to Dr. Randy Shaver, who is a professor emeritus with the Department of Animals and Dairy Science at the University of Wisconsin-Madison. These days, Dr. Shaver is also a principal at Cows Agree Consulting. Randy and John, well, we're going to turn it back over to you and help us understand how we should evaluate corn silage impact on the environment and dairy business performance. Randy?
Thanks, Corey. And John, thanks for setting me up with some of the production data and quality data that we'll go through and apply it in some different areas. And certainly good morning to some of you and probably good afternoon to others. It's certainly a pleasure to be here. Oftentimes we get to kind of the end of the road with our dairy studies, and that's the performance data and maybe some hopefully animal health data, some rumen function, and we maybe don't take it the next step. And I'd certainly like to credit the Enogen team for looking further and took rather novel approach, I think, in looking at this sustainability topic, which has become very, very important throughout the whole supply chain, and certainly at the consumer level and the producer level, and did a life cycle assessment and actually employed a third-party firm that specializes in this. And I guess I would direct you to the bottom portion of the slide. And for this life cycle analysis, or the LCA, if you will, they really looked at from the production of the seed right up through the production of the corn at the farm, the growing, the harvest, feeding, right up to where that milk hits the truck to leave the farm. And just kind of in the middle of the slide, you'll see for the work that that group did, they looked at 1,000 cow herd, 850 cows in milk. So next slide. So essentially, you would take that feed efficiency data from the Penn State study that Dr. Gazer just showed us and apply that through this LCA analyses, and you can see when you look at the impact, the reduction in these key sustainability measures is somewhere in the area of 4 to 6%. So we're looking at climate change or global warming potential, energy use through fuel, land use, water consumption. That's not water consumption by the cows, but from this whole systems approach. And so very significant that impact of improving feed efficiency leads to improvements in these key measures of sustainability. And one of the things I've learned from studying this more now is that this whole area of LCA is really its own science. It's applied to many different industries and many different products. They do some very sophisticated statistics and sensitivity analyses. And there are actually international standards for how these studies are done and how they're reviewed. So you can see what those percentage reductions were. And I would point out that another study at Ohio State University shows those same type of changes, improved feed efficiency, and then these reductions in these measures of sustainability, reductions in global warming potential, et cetera. Next slide, please. So if you're like me, sometimes I can't quite get my arms around things like carbon credits, and sometimes percentage changes, as Corey alluded to previously, maybe are hard to grasp. And there is on the internet, and you can see at the bottom of this slide, it's actually a generic program calculator put out by the Environmental Protection Agency, where you can convert some of those measures of sustainability into maybe some real life measures that we can understand. And so you can see that improvement in feed efficiency on that 1,000 cow dairy of 3 to 4% would transfer into cars, 314 cars. You can see football fields, something that we're all very attuned to this time of year, a little less than 200. Swimming pools, 21, and then finally just power or energy use for the average home. So I think this is really a very nice and novel way of taking some of our dairy technology and carrying it through to some numbers that we can all kind of grasp. And just to point out, it all goes back to those cows and the improvements that we saw in feed efficiency. Okay, next slide. So one of the areas that I was very much involved with, as well as Dr. Gazer, was trying to do some analyses of the economics from this improvement in feed efficiency. Again, we based this on the Penn State performance study that we presented. The numbers, again, from the Ohio State study, very similar improvements in feed efficiency. The numbers are maybe slightly different, but the trends are the same. And we also, for our calculator, we need to have agronomic yield data, because oftentimes when we improve quality, we can lose some yield in the field. And so we've tried to track the agronomic side as well as the cow side in this analysis. We went back to a program that John and I and some other colleagues at the university have developed a number of years ago to kind of assess the impact of cow performance as well as agronomic yield. And we essentially took that spreadsheet, which I'll show you here in a few minutes, and adapted that for comparing the Enogen hybrid to a comparable non-traded hybrid. Okay, next slide, please. So anytime you run these models, you need to have some inputs. And so again, we went to that Journal of Dairy Science study from Penn State for their intake, production data, as well as their diet composition. Obviously, milk price is a big impact on this. And so we used 2022 numbers for the federal milk marketing order. January through August of 2022. We took August 2022 feed cost, and we used the Northeast numbers because it was the Penn State study. And then we had agronomic yield data from multi-year and multi-location studies performed through the Syngenta agronomy team for the Enogen hybrids. Again, we wanted to keep this in line with that life cycle analysis, so we used this simulation herd of 850 milking cows, and we also used a corn silage production cost of $850 per acre. That would be a total cost, variable and fixed. We got that from some Iowa State Extension materials. Obviously, that varies from year to year and location, but we kept that the same for both hybrids, because I think earlier Dwayne alluded to the fact that there's really no difference in seed cost, and we don't really see any differences in fungicide use and other agronomic practices. So those were the seed numbers that we used in the spreadsheet. Okay, next slide. So in terms of the outputs, and I'll show you in the next slide kind of what this looks like, but we've got the income for the herd, the feed cost, and then the important variable is the income over feed cost for the milking herd. And then really what we're looking at here is the difference between the Enogen traded hybrid and the control hybrid or the untraded hybrid. So if we look at the results, we see on average, it came out, again, based on those Penn State feed efficiency numbers, $174 per cow. There is variation there, primarily related to variation in milk price from month to month in this past year thus far. And you can see that ranges from $132 on the low end to a little over $200 per cow on the high end. And then if you take that back to that 850 cows on average, that difference in income over feed costs was a little less than $150,000 for that herd for that year. So very substantial economic benefits to go along with some of those sustainability improvements as well. Okay, next slide. This is the model, and I just refer you to this because at the bottom of this slide, and when you get this and can look at it maybe in the archives later, you can click on that link and actually go into this sort of spreadsheet and spend some time with it on your own numbers. But on the kind of upper left quadrant, we can see you can change the number of cows, and it's in there at 850. You can change the intake and performance data. We inputted exactly what came out of that Penn State study that John presented. You can change the milk pricing numbers for fat, protein, and other solids, a somatic cell adjustment. What's in here currently would be the average for January through August of 2022. And then it kicks out your milk revenue per 100, milk revenue per head per day and throughout the year. Over on the right side of that, kind of the upper right quadrant, you put in the percentage corn silage in the diet, you put in the yield. Again, going back to Dwayne's numbers, not seeing any real up or down in yield. So it's 24 tons of 35% dry matter silage. You put in that $850 that I mentioned for production cost per acre, and it calculates a cost per ton of silage. And then that all factors in the income over feed cost. And you can see the bottom line number at the bottom right quadrant, $174 per cow per year. Obviously, if you go in and start changing animal performance, change some of these inputted values, you're going to get some differences, certainly in milk revenue and feed costs. But the important thing is you want to look at the differences between the control and the test hybrids. We did some sensitivity analyses, and I'll turn this back over to John in a second here to discuss some of that. But the big gorilla in the room is obviously milk price, and that does vary, and John will talk about that, but that certainly drives that difference between the low 100s to the a little bit over $200 in the response to the Enogen. And we do get a lot of questions about the cost of the TMR, the other ingredients beside corn silage, the haylage, the corn grain, soybean meal, etc. And we did a lot of work with that, and it really makes a very, very minimal impact on the income over feed cost difference between the control and the test. Really, the big one is the milk price differences. So John, if you'd like to carry that on, thank you.
Absolutely, and I'm going to reinforce a couple of aspects of what Randy just described. That worksheet prior, that I'm sure seems pretty daunting to you all. Randy and I have lived and breathed that over the last 5 years, or on some level worked with that tool in a number of different ways. But I'm gonna contend that using that worksheet, which is available from Dr. Joe Lauer's website, corn.agronomy.wisc.edu, as a tool in your toolbox for evaluating seed genetics, that's what we should be doing to evaluate our seed genetics and our ingredients year in, year out. Their margins are too tight, and many of you may not think about our neighbors to the west, but I know corn silage, for example, this year is now valued at dairies in excess of $125 a ton. Here in the Midwest, it's certainly less than that, thanks to Mother Nature gracing us with rainfall, hopefully through a lot of areas. We've had some drought, but we need to step up our evaluation of seed genetics. And as we've discussed and written about in the past, for every 500 cows on feed, we're going to have easily $250,000 into that total feed cost. In some cases, 300 to maybe 350,000, just depending upon our input costs. So Randy and I, and Bruce Jones and Joe, we put that worksheet together to highlight all of the needed inputs to appropriately evaluate the business performance of any two side-by-side seed genetic options. And through our work with that tool and then putting it into play here, I'm proud of this effort that Randy, Dr. Eileen Watson, myself had a little bit of contribution as well. We looked at utilizing this tool and evaluating a number of different conditions. This slide now here, getting to this bar chart, represents some of what Randy spoke about, however, just graphed out. So it's one thing to use a tool such as what Randy talked about just for one set of conditions. However, as we've used this tool in different ways, different spots, it's also important to adjust some of the conditions, for example, milk pricing, component pricing, and then measure and see what kind of outcomes. So what we have here are the January through August federal milk order prices and the impact on the financial outcome when run through that worksheet. So Randy spoke about this before in terms of the range, but the green bars highlight the response or the revenue advantage associated with the Enogen technology relative to control for the herd, just in terms of total revenue. And then also in the black represents the income over feed costs. So we see graphically the range in responses that Randy spoke about before. Next slide, please. So I work with River Laboratories, the University of Wisconsin, with Randy, Dave Combs via Cows Agree Consulting, wearing a few different hats, as well as being a father of a 7- and 9-year-old. Figured that's not enough, so I moonlight in beef nutrition as well, and can't do any of them well, so why not just try doing something else? So I say that somewhat tongue-in-cheek, but I bring up the beef nutrition because here in this slide, it's presented in a similar fashion, a lot of content here, but there is quite a bit of data out there in beef nutrition, in beef feeding studies from University of Nebraska, Kansas State University, to name a couple of spots where there have been several trials. And what I'll acknowledge is that there have been similar observations through beef feeding studies relative to the dairy in terms of feed conversion efficiency responses than when utilizing data and observations from those published studies in the life cycle assessments. I've learned a lot about life cycle assessments over the last year. We see some similar reductions in environmental impact or improvement in environmental stewardship. And so just to make mention that this is not strictly a set of dairy observations in feeding studies, but we also have quite a bit of data and have observed quite a bit on the beef side as well. So with that, I'm going to kick it back over to Dwayne as we are nearing the finish line.
Great, thank you, John and Randy. Interesting stuff that you put together and presented for us here. Let me just recap a bit of what we've heard today. And for my own purposes, I generally find that I understand some of these complex concepts a little bit better when I just break it down to some simple concepts. And that is something that we've mentioned several times today, doing more with less. So when we think about economic profitability, anytime we can reduce input costs, it certainly helps us to return some savings to the operation. When we're thinking about the perception of livestock production on sustainability, the environment, climate, anytime we can do more with less, that will reduce the impact or the perceived impact of livestock production on the environment. The data that we've seen today really resonates in all of those areas. Just about every way we research Enogen for livestock feed and beef and dairy production, the results come back very consistently. You're going to see feed efficiency gains of around 5%, feeding Enogen corn either as grain or silage to beef or dairy cattle. When we plug the research numbers into the LCA, the life cycle analysis, once again, if you're struggling to remember some of the results, think about that 5%. The results really showed about a 4 to 6% improvement or reduction in environmental impact in dairy production when you feed Enogen corn versus non-Enogen corn. And lastly, I think one of the issues that is key to producers today, when you're holding your feed costs constant or reducing them, holding production constant or increasing them, you're really affecting the bottom line of that operation. And these results showed the potential of returning some significant money to a dairy operation through reduced feed costs and potential production enhancement as well. So the key thing I think for producers to understand is that it's relatively easy to incorporate Enogen silage into a dairy operation. We typically find and recommend to our producers, simply replace the corn you're currently feeding with Enogen silage. It's the easiest way to do it. Your nutritionist will balance the ration from there. It's relatively easy to incorporate this technology into a dairy operation. So that's all from here. Corey, back to you.
Well, thanks a lot, Dwayne, Randy, and John. We're going to go to a poll question here before we actually answer audience questions. This poll question is simply rating your optimism level about the dairy industry in the next 5 years. Highly optimistic, lots of opportunity, somewhat optimistic, good but challenging, somewhat pessimistic, looks tough but will be still be milking cows, and pessimistic, industry environment not looking good. So let's go ahead and see what you're all thinking in that regard. And as soon as we see these poll results, we're going to move to some poll questions. And when we do that, we're going to bring up slide 13 as a indicator to Randy and John that we're going to be talking about amylase here, that amylase slide. We got a couple of questions in. So let's see what people's results are here. 45% of people answered this one. 63% somewhat optimistic was the leading category here, and with highly optimistic and somewhat pessimistic flanking these. I had the opportunity to serve as MC of the Global Dairy Symposium here on Thursday at World Dairy Expo 2 weeks ago. And Torsten Hemme, a German economist who has done a lot of work in dairy, he posed the question to the Americans in the audience. He says, are you ready for America's golden era of dairy? Golden era of dairy, because what is happening here around the world, New Zealand, the #1 dairy exporter, and the European Union ranks 1 and 2, with the US ranking 3rd. We will be the source for growth in dairy product exports. In 1995, we were a non-player, and now 17% of our milk, or enough milk from cows 1 out of 6 days a week, is going to international customers. For that reason alone, I am in the highly optimistic category. So we're going to pull up slide 13 here so the audience can see where these 2 questions come from. I'm going to turn this over to Randy and John, and I'm going to merge both questions together here. Why is amylase higher? That's the first question. The second question is, does the amylase enzyme lead to higher levels of sugar and lower starch? So if you guys can comment on those 2, looking at that slide there, the data on the far right.
I can go first on the amylase, John, and kick it over to you for the starch and sugar question. But essentially, the amylase is part of the corn kernel. So as that kernel matures, you increase amylase. This data, as I recall, was actually in the silage from that Penn State study as it was being fed out. So this would indicate that amylase is still active in that silage after it's fermented. And so it would have the potential to have effect on the quality of that silage as it's fermenting in the silo, but then also delivering amylase to the animal to have effects there as well. So and it is very significant, and this was on the silage coming out of the silo at the time of feeding. So John, if you want to follow up.
So the starch versus sugar is a good question, and this has been an area that Randy and myself, our team, we've carried quite a bit of conversation. So think of starch like a logging chain. You've got a big chain with a lot of connecting points, and so starch in its intact form is like that intact logging chain. What amylase does is it will chop up starch into smaller fragments. There are exo amylases and endo amylases, but the amylase within Enogen, it will cut up that logging chain of starch in sort of random spots throughout. So the starch is still starch, but it exists in smaller chain link fragments. So as that starch breakdown continues over time, assuming that amylase is active, eventually the chain lengths of glucose and starch will get small enough where they'll start to be picked up by a sugar measurement at the laboratory. So there is a conversion of starch into shorter degree of polymerization. I told you I wouldn't use another big word. All right, I used another big word. But we're converting starch into sugar, but it gets to be a little bit of a gray zone at times with laboratory analyses as that starch is chopped up into smaller and smaller fragments and ends up turning into sugar. So I hope that has helped address the question, but we do have, I think, some more to learn in terms of just the nutritional characteristics of the glucose and those carbohydrates.
Dwayne, the next question is going to be for you from the audience here. Is the Enogen corn here, is it a GMO and must be fed to livestock, or is it standard hybrid traits here?
So the Enogen trait is a genetically modified trait. So an Enogen corn hybrid would be considered a GMO corn hybrid. It's important to note that it's fully approved for food and feed use in the U.S. and Canada. So these hybrids and the resulting grain or silage are fully approved to be in the U.S. corn supply and be fed to livestock.
Okay. And there's no planting restrictions at all? You can plant anywhere, correct?
The only restriction that we ask our growers to grow this essentially as an identity preserved crop. So for a silage producer or a dairy producer growing their own corn silage, it essentially amounts to good record keeping. We ask them to know where their Enogen corn is grown, where they're going to store it, and of course that they're going to feed it in their own operation. So it's a very simple record keeping process for a dairy producer.
John, I think this next question's for you, but before I ask it, I want a clarification because you made a really profound statement and I missed a word when I wrote it down. Every 500 cows we feed have $250,000 in what costs? Feed or corn?
That would be feed costs attributable to corn silage. That is all of the cost sunk into producing silage that Randy has really helped me think about. But it's the tilling the ground, putting the seed in the ground, the cost of the seed, the fertility, the agronomic practices, harvest, all of that wrapped together, roughly $250,000 for every 500 cows.
Okay, I wanted to bring that back up as a setup to this next audience question. We have a lot of questions coming in, very active audience here. To compare feed cost, was the starch level the same or less with Enogen corn silage to represent similar TDN, total digestible nutrients? Randy and John?
I'll jump on this first, Randy, maybe to defer to your meta-analysis. I don't recall any significant decrease in starch content in Enogen. Randy, can you speak to the observations from the meta-analysis you've done?
Well, I think it was getting back to the economic calculations. The way the Penn State study was set up, it was the same percentage of corn silage in the diet in that particular study. I don't think there were major differences in starch concentration, so they would have been fairly similar. There was not any attempt to adjust the starch concentration up or down in the economic analyses, and that's really why that difference in feed cost why that non-silage part of the diet had minimal impact on the economics. But obviously, when you get into different situations, you would certainly want to look at starch content and whether you had to add more corn or take corn out. But using the Penn State data, there just wasn't any need or opportunity to do that.
The next question comes in from another audience member. Is it common to see higher starch values on your feed analysis, or are you going to see the advantage from higher starch availability and better feed efficiency here with the Enogen brand from these studies?
I can jump on that. It would be the latter. So when we look at the starch contribution, the grain contribution to your energy value per pound, per ton, per acre, it's a function of total starch content, but also the starch digestibility, availability in the dairy cow. So with the Enogen technology, the trait, what we've observed has been a consistent and reliable increase in rumen starch digestibility, total tract starch digestibility, in a lot of the feeding studies as well. So it has not necessarily been greater grain, but more digestible grain and starch.
Yeah, the other thing I would add, Corey and John, is obviously growing conditions affect grain yield and starch concentration. The genetic contribution to this would be through starch availability, but certainly it's important to test for starch and NDF and adjust accordingly. But the trait effect would be on starch digestibility.
Our next question comes in. Will NIR samples be able to adjust their results to understand this corn silage? I think, John, you're probably best suited to answer that one.
Oh, so near infrared is commercial feed testing, and what near infrared commercial feed testing models do is they rely upon many thousands of observations in wet chemistry at the laboratory to predict the nutritional value for the sample and future results. And so measuring starch content, fiber content, very reliable measures. Fiber digestibility, that also is a very reliable measurement through commercial feed testing. Starch is a little bit different in maybe a couple fashions. So with Enogen technology, due to the enzyme acting within the grain, within the animal, near infrared commercial feed testing may not be the right analysis approach to determine the actual starch digestibility in the cows. We might opt to actually hang samples or put samples in bags and incubate them in the rumen of cows for 7 hours to determine the outcome or the potential response. The other aspect to commercial feed testing where NIR may not be the best tool for assessing starch digestibility is tied in with particle size. The commercial feed testing samples are dried and ground and homogenized, very fine powder, and then they're analyzed with the near infrared commercial feed testing instrument. The particle size is not considered at all, and we know that is a very, very substantial factor. I've learned from Randy over time, both in grain and corn silage, that kernel processing score is not accounted for with commercial feed testing. So that needs to be taken into account.
And amazingly, our presenters cannot see the questions coming in here, but the next question is actually on processing and microns, and we're going to send that one over to Randy. The silage data looks good, says this one audience member. Does grain, if processed under 400 micron or steam flaked, would you see benefits in dairy rations?
I'm actually going to kick that one back to John because John's been working on that more than I have in the past couple of years. So.
Yeah. So steam flake corn is kind of a beast in that it's tough to model with. We know that the density is decreased and it might actually float or hang up in the rumen a little bit longer, resides in the rumen a little bit longer, kind of like if you're floating around on a beach raft as opposed to a raft that's sinking and going with the current of the river. But speaking to the mean particle size and microns, we've sort of shifted our goalposts over the last few years, and there's been two aspects of that. One, I think commercial feed mills and today's rollers and on-farm equipment have been able to achieve smaller and smaller and more fine particle size, or finer and finer particle size. One other aspect of it, and it's been a bit confusing, is the laboratory, River Laboratories, updated the particle size technique in the last couple of years after recognizing that corn grain gets hung up in the analysis sieve. So The benchmark at the moment for samples analyzed by River Laboratory is in the 200 to 300 micron range, if you can believe it. So we want to be more aggressive, recognizing that, yes, indeed, mean particle size is tied to rumen starch digestibility. Randy and I have worked on that, published a paper, what, Randy, 2018, 19, something like that, in Professional Animal Scientist or Applied Animal Science. We've got some new data available as well when we've looked into Rock River's database, and it looks like there's a pretty strong relationship between particle size and rumen starch digestibility. So stay tuned what's to come forth there, but the goal is 200 to 300.
Dwayne, I'm going to send this next question to you, and I think you're most likely to answer it. The question is, in the silage corn plants in this study, and that were ultimately compared, what were the heat units on those high beds, or what was the, maybe the follow-up question, what was the growing day on those corn silage?
I would assume the question refers to the yield data that was shown early in the presentation, and that would have been a compilation of several different production trials. So not sure I could answer that specifically because it's going to vary between locations. And we had several different locations, some that were Syngenta contract research, others that were conducted at universities. So a wide range of growing conditions that were compiled to achieve that data.
John or Randy, question comes in, will this Enogen corn silage affect or impact protein requirements?
Yeah, I might jump in, and John, you can give your thoughts. That's actually an area that is kind of a topic that's coming up more and more, and one that we'll probably do some more research on, and that's essentially related to microbial protein synthesis. I don't know that that's been looked at directly in the dairy side, maybe a little bit more in the beef side. We're not really seeing major upsets or changes in rumen fermentation in terms of VFAs and pH. So I don't know that there would be any downside to microbial protein output that would require more protein. On the other hand, with greater carbohydrate availability in the rumen, we often would expect microbial protein output to go up, which would allow us maybe to be a little more conservative on protein nutrition. But that's probably a researchable question at this point, and one that needs to be looked at in a little more detail. I don't know, John, if you want to add to that.
No, I think that's pretty well said.
Okay, we got 3 questions in the queue, so we're going to go through those and kind of call speed round here. So is the higher level of amylase that makes the Enogen so much more digestible and that you can feed it right away? Are you getting the same results on fermented conventional silage? So this kind of talks a little bit to the slide that you had earlier in the slide deck. I think really is where this question is coming from.
Yeah, I'll speak to that. If we would look at what maybe that amylase being expressed, an increase in starch digestibility, what that might correspond to in terms of fermented conventional silage, I want to say Dr. Eileen estimated that it was somewhere around 150-day fermented silage. So that day 0, first couple of weeks silage may feed like it's been fermenting for 3-4 months.
The next question is, any concerns with feeding higher corn silage diets over 50% dry matter using Enogen corn silage?
You know, there haven't been much from the feeding studies in terms of rumen pH, or like Randy mentioned before, changes in fermentation characteristics or measured fermentation in the rumen. So I don't think so at this point.
Okay. Our final audience question, and I mean, this might be an all play for Dwayne, Randy, and John. Would you see more benefit from Enogen if you were feeding both Enogen silage and Enogen dry corn?
Good question. I don't know that we have the data to really nail that one down at this point. Dwayne, Randy?
Yeah, most of our data on feeding grain comes from the beef industry, and we see very similar results there, but we do not have much data feeding grain and silage and dairy. So agree with John there, probably need some additional info there, but once again, we do see essentially the same level of feed efficiency effect feeding whole or dry rolled corn in beef production.
Yeah, that's maybe been looked at in a few treatments that I can recall. I don't know that there's been any downsides to feeding all the corn coming from Enogen, both silage and grain. On the other hand, I don't know that we've really seen any major upticks. So, but it's not been, it's not been a lot of treatments, a lot of study, and it probably something that needs to be looked at in a little more detail. But I think it's been done enough, both commercially and in research trials, that we just haven't seen any negatives that I'm aware of.
Well, thank you to our audience for those very insightful and thought-provoking questions. I want to thank our panelists also for their deep responses on them. And if there's any other questions that come in, we certainly would be able to answer them after the webinar. Following this webinar, all audience members will receive a short survey about our program. Please fill that out so that we can help better plan future webinars. The questions are going to be, do you own or manage a dairy operation? Please rate the quality of the webinar you attended, with 1 being poor and 5 being excellent. Please rate the quality of speakers, again, 5 being the top score. Rate your level of interest in the information presented and scale 1 to 5, with 1 being low and 5 being high. And the final question, would you like more information on Enogen corn from Syngenta? If so, provide your email or other contact information, and we will get you some more information. Thank you in advance for completing that survey. And on behalf of Dr. Dwayne Martin, Dr. Randy Shaver, and Dr. John Gazer, I am Corey Geiger and your host. Thank you for joining us today on this special Hoard's Dairyman webinar with sponsored by Enogen and Syngenta. We wish you all a good day. Goodbye, everyone.